Picture this. You're living aboard the International Space Station and need a special tool. The only problem is your next supply vehicle won't deliver this tool for a couple of months. What do? Stick with me for a few minutes to find out. Hi, I'm Sunny Williams, and today we're talking about 3D printing in space. Let's jump right in. Keeping a large quantity of every possible item we may need aboard the station is challenging. Space is limited here, and launching cargo is expensive, costing thousands of dollars per kilogram. This is a challenge that will continue with NASA as it expands its presence beyond low Earth orbit. To help solve this issue, NASA is experimenting with additive manufacturing or 3D printing aboard the International Space Station. This manufacturing technique uses a supply of one material to gradually build an item by slowly laying down thin layers on top of each other to build a three-dimensional shape. This allows us to keep a single supply of material on the station that can be used to create a variety of tools, parts, or other items we might need. Long strings of raw material, called filament, are fed into a heating element where it's melted and constantly fed through a small nozzle called an extruder, while it moves around, drawing the shape of an item being printed. After a layer is completed, the extruder lifts slightly and prints the next layer directly on top of the previous layer until the product is complete. The design for each part is created down on Earth using 3D design software. The designs are sent to us here on station as electronic files to program the exact movement of the extruder to make precise shapes. Our 3D printer uses PLA plastic, or polylactic acid, which is infused with copper oxide, which has antimicrobial properties to help keep our station environment safe. Here, in the microgravity environment of space, warm air does not rise through convection like it does on Earth. The heat generated from the printer would cause a pocket of warm air, which could continue to get hotter and hotter if we didn't circulate the air with fans. The fans also help to dissipate noxious fumes that could concentrate around the printer if not blown away. Some items we print are sent back to Earth to be inspected for strength, layer adhesion, and print quality. This will guide improvements for future generations of 3D printers used in space. NASA is also looking into using 3D printers on a much bigger scale. Studies and experiments are being performed to create 3D printed habitats that can be used in the future on the surface of the Moon or Mars. The goal is to use resources such as rocks, soil, water already found at these locations to make a type of concrete that can be used to print entire structures for long-term habitation. The Crew Health and Performance Exploration Analog is a series of missions which participants are secluded for an entire year in a 3D printed habitat known as Mars Dune Alpha. These analog astronauts perform science experiments in simulated spacewalks to help test the suitability of such structures for long-term habitation. I am so glad you can join me to learn about 3D printing in space and how it helps making space exploration more sustainable. Can you think of any more ideas on how to use 3D printing in space? How about some challenges the environment of space may pose on 3D printing? Discuss these ideas with your classmates before doing the activity. We hope you'll join us again for our next demonstration. See you soon!